So this demonstration is for assignment 6, the stopwatch using the JTAG UART and timer. The primary goal of this assignment is to design and implement a fully functional stopwatch using the DE2 FPGA board. The stopwatch will leverage multiple hardware and software components, including switches, LEDs, 7-segment displays, a timer, and JTAG UART for communication. The purpose of this is to develop a deeper understanding of how communication and interfacing with the various peripherals manage interrupts and implement real-time systems in a hardware software code design environment. The problem statement for this is to just create a stopwatch application that can start, stop, and reset. So we want to display the elapsed time on the 7-segment display, and the stopwatch will be controlled with the switches on the DE2 board, and it will indicate its running state using the LEDs, so just letting us know that it's on, and the status message will be sent to the terminal using the JTAG UART. So the components that we're using here are the switches, we'll have it as a start and stop switch, the reset switch, and the LEDs, that's the indicator, the 7-segment display, which will display the time, and the timer, which will keep the time, and the JTAG UART for the status message. And that's pretty much the objective here. So I'll go over the code now. Here's the code we have. So we have the clear all function here. This just clears all of the LEDs or anything displaying on the 7 segments. And then we initialize a timer and initialize a switch, which will also activate the IRQ for both the timer and switches. So we'll just go and look over the timer, initializing the timer. So first we stop the timer controller with the high bit of 8. So we just put the 8 here, and then we set the clock for 1 second by multiplying it by 1000 a millisecond to the system timer load value. Then we assign the periods accordingly, then turn the timer back on, and then after that we write to the IRQ register. The next thing we have to do initialize is the switch interrupts. So we'll have initialize the switches here, which is very similar to the timer, except we don't have to turn off the timer because there's nothing running. So we just put in our IRQ mask for the switches that we do want to be interrupted. So that's for switch 0 and switch 1. So we just do up to 3, and then clear the edge capture register so it's not reading anything, and then we write to the IRQ register along with the ISR that's here, and the same for the timer. There's this timer ISR as well. So for the timer ISR, it's simply just running the time, checking if running is high. So this will change based off of the switches. So if running is not high, then it's just going to stop the timer. So that's what we want. I don't think we need the debounce here, so it should be fine the way it is. And then for the switches, we have the switch ISR, which we will load the switch and read the switch value that we're getting, the edge capture of the switch base, and then we're checking. We clear the edge capture because we're done with that because we already got here, and then we're ANDing it with the bit that we're looking for based off of what the switch is. So if the switch is switch 0, which is 1, then we are going to toggle running, because that means that we either started or stopped. So that's why we write running equals not running, so that every time it goes back to here, it can start and stop. So same process as for the timer. We have the started state here. If it's running is high, and if it's low, then it's going to be stopped, and it will display here on the JTAG UART, and I will show the function of how the JTAG is on the bottom. Then the next one is checking for the next switch, which is switch 1. If it's switch 1, then it's actually resetting the it's resetting the time, and then we're going to display the time here, and the time actually is also in the timer RSR as well, because it's just being incremented, so it just gets reset to 0. We display the time there, and then we actually don't need to display it here. So if it's being displayed in the time, we can actually display the time first, and then we can increment it. Or yeah, so let's just do that really quick. Okay, so that should be better. We don't have to keep rewriting stuff. So that's for the switches, and then we added a debounce on the switch because we don't want it to keep reading these switches again, so just adding a debounce so it can read everything accordingly. After that, so there's the clear all, there's the unsigned hex display, or the 7 segments, and then here is the JTAG UART. How to write to the JTAG UART. So we're feeding the message, or the character, or the string, into this function, and then while it's reading the message, it's going to write to the JTAG UART data with whatever the JTAG UART name is. Just check in the system header file, and then you increment you point to the message and increment it after every string, so that way it can print it accordingly. And then we have our function prototype on top, so our main just lays right here. So now I can demonstrate the board here. So I'll just run as. Okay, now we will start recording now. Yes. Here's a demonstration of the board. We have the code running, so we're going to actually start the timer here, switch 0. So this is starting it. It's counting, and then we're going to stop. And then we're going to reset. So, and then we start again. And then we can actually reset while it's running. So, yep. So that concludes the demonstration of my board.